Welcome to Nemesis Tech. Today we're going to discuss about data types. Little bit very important concept here. Here we can able to see data types. The syntax for data type, that is, we have to mention the data type. Already we know that data types are character, integer, float, void, all those things. These are all comes under data types. So please mention the data type first here. Again, identifier or variable name, that's what X, whatever the identifier you are going to mention for that particular data type, you mention that. So like here, you can able to see the example character having the identifier that is ch. Again here for integer data type, we have a identifier X. We will call this one as a variable name also. Again, they have assigned the value that is equal to 55. Again, float F is equal to 22. So like that, we can able to uh, declare the variables. We can able to declare as well as we can able to define the variables here. For example, here for the character data type, this character data type, it will help you to tell very clearly how much amount of memory will going to be consumed, whether it is 1 byte or 2 byte, like that it will going to say. So that is the reason why we will going to use the data type. When I say character data type, it indicates very clearly character data type provides 1 byte of memory. That's why we mentioned here 1 byte of memory it will going to provide. You can able to see the example of this. So ch is my variable, character data type variable. Again, it have some positive address, memory address, that is 20223. You can able to store A, but whenever you are storing the character values, you must include like this. For example, ch here character. Uh, Suppose let's take it a variable as a something like gh or anything gh. I will take the variable, so that is equal to, so whenever you are mentioning the character type, you have to mention the value in the single quotes, that is a, again semicolon. So this is the way you will going to mention the character type. So this is how you are going to define the variable, that is gh. Okay, so that's why I mentioned you can able to include special type of symbols or alphabets, anything a. So either you can able to initialize integer also as a character. So this is one thing. Again, when you go back to this integer, for that you can able to see this diagram. Integer x is equal to 55. X is a memory variable. Okay, again this memory will going to have some address. All the memory will going to have positive address 2055 something like. So every memory consists of positive address. Here I stored the value that is 22. Either you can able to store -8, anything, but you can store decimal value also like this. Here decimal value, but it will not going to accept after the decimal number, after the decimal point, whatever the number you will going to provide, it will not going to accept. That is the limitation of integer type here. To overcome that one, we have a one more, that is called it as float type. So when you mention this, you can, it will going to take integer value as well as it will going to take real value, nothing but decimal. It includes decimal points as well. So 55.66, it will include that. Again -55.36, it will include that. Suppose if I mention like this, for example, if I mention 55, okay, still it will going to accept the value, but whatever the value it will going to accept, it will going to accept like this 55.00, like that it will going to accept, nothing but it will going to accept real values. So that is the reason why we will going to use the float type over here. So this is all about syntax of the data types and how to declare a data type and how to define a data type. Again, come back here, you can able to see here. So we know that very clearly 8 bit is equal to 1 byte, but you need to know one more important thing over here is very simple one and easy one. That is, you can see 8 bits is equal to 1 byte. We know this one. 8 bits is equal to how many bytes? 1 byte. And few more things. Basically, we need to understand 1 bit is equal to how many bytes. We need to understand. So let's see that one. Here, please see this table. It's a very important table. You can able to see this table, bits to bytes conversion table. So this table helps you to understand so bits and bytes. So 1 bit is equal to 0.125 bytes. 2 bits is equal to 0.125 bytes. Again 3 bits is equal to 0.37 bytes. 4 bits is equal to 0.5. Again, so 4 bits is equal to, we call this one as nibble. Okay, 4 bits means it is a nibble. Again, 5 bits is equal to 0.2625. 6 bits is equal to 0.75 bytes. 7 bits is equal to 0.875 bytes. 8 bits is equal to, totally we will get 1 byte. If it is 16 bits, then it is 2 bytes. So that is how you need to understand. This is very, very important table. Please be careful with this. Let's discuss about classification of data types here. Data types are classified in different varieties. You can able to see primitive and non-primitive data types. Basically, we haven't wrote anything like non-primitive, but these are all comes under non-primitive data types. But what we have to understand here, so in the primitive data types, there are, we will call these all these data types. We will call these all these data types as basic data types. That is integer, character, float, void, and double. All are belongs to basic data types. That one we call this as primitive data types. When it comes to derived data types and user-defined data types, all these are comes under non-primitive data types. So here, when it's go to derived data types, arrays, strings, pointers, functions. When it comes to user-defined data types, that is structures, unions, enumeration, again type def. These are all belongs to data types. Basically, these are the classification of data types. Very important one. Again, we will going to see the sub-classification of the data types here. So in the classification of data types, we have sub-classification. So you can able to see. So I am discussing about in the sub-classification. So only I am discussing about primitive data types. I am not discussing anything about non-primitive data types, arrays, functions, etc., etc. And we are not discussing right now. Again, here one more important thing you need to understand. Here we have a primitive data types in that integer, character, float, and void. These are all comes under primitive data types. In the integer, we have subdivided the data types, that is short, integer, long. Okay. So short is what type, that is signed or unsigned. Okay. Again, when it comes to short, you will going to find signed. Again, when it comes to short, you will going to find the unsigned data type. So what is this signed is nothing but it will going to hold both the values, that is positive values as well as negative values. Again, unsigned is nothing but only it will going to hold positive values. Basically, short will going to provide 2 bytes of memory. 2 bytes of memory. When it comes to integer, here it will be signed as well as unsigned. Here it will going to provide 2 bytes or 4 bytes of memory based on the compiler. Okay. Again, in integer, we have a long data type, that is signed and unsigned. Here it will going to provide 4 bytes of memory. Again comes to the character. So when it comes to 4 bytes, 2 bytes, or 4 bytes, whatever. So here you can able to see 1 byte is equal to 8 bits. You can able to see there are 16 bits is there. 16 bits is nothing but 2 bytes. Nothing but what short provides. You can able to see this short data type will going to provide 2 bytes of memory. So nothing but, so here you can able to see 16 cells are available. Nothing but each cell will going to hold 1 byte. Sorry, 1 bit. Each cell will going to hold 1 bit. This cell will going to hold 1 bit. This cell will going to hold 1 bit. Again 1 bit, 1 bit, 1 bit, 1 bit, like that. Each and every cell will going to hold 1 bit. Okay, so 8 bit is equal to 1 byte. Again, one more 8 bit is equal to 1 byte. Nothing but 8 plus 18, 16 bytes. Nothing but here 1 byte plus 1 byte is equal to 2 bytes. So that is what short will going to provide 2 bytes. Here 8 plus 8 is equal to 16 bytes is equal to 2 bytes. So in this, go to the character. Here signed and unsigned is there. Here signed is, we need to understand very clearly. Signed is nothing but it will going to occupy positive and negative values. When it comes to unsigned, it will going to occupy only positive values. Okay. So here this character provides a memory 1 byte for every value. Again, float. So it will going to have a subtype over here. You can able to see float, double, long double. Float will going to provide 4 bytes, double will going to provide 8 bytes, long double will going to provide 10 bytes. Finally void. Okay, nothing. So again, one more important thing, why these data types are very important, and why this memory, these data types are providing such kind of memory, 2 bytes, 4 bytes, 8 bytes, 10 bytes, like that. Because for example, I wanted to store a number. Okay, I wanted to store a number, suppose example 10. So this number required 2 bytes. It is a short number, short data type number. 2 bytes is more than enough. If I take integer, it will going to provide 4 bytes of memory for this particular number, 4 bytes of memory. So this number required only 2 bytes, but another 2 bytes are waste, right? So that is the reason why we will going to introduce such kind of data type, short, integer, long. Suppose for example, account number. Suppose the account number, if you go to the bank, so the account number looks like this: 102456789. Okay, 55, 14 digit number, or 18 digit number, or 16 digit number, account number will be there. Such kind of number we wanted to store. That time what we're going to do, we need more memory. That time we cannot able to use the short here. Yes or not? That time we cannot able to use the short. Again, we cannot able to use the integer. So that time we need more memory. That time what we will going to do, we will going to use double, long, double, okay, long, like that we will going to use. It will going to provide the more space, nothing but more bytes of memory it will going to provide, more bits of memory it will going to provide. So that is the reason why these data types are very important. Okay, so uh, why data type? Okay, so why data type? It is very important because it will going to provide the memory. Okay, so according to your uh, type. Okay, so if it is integer, it will going to provide 4 bytes. If it is a long, it will going to provide 4 bytes. If it is a float, provide 4 bytes. Double provides 8 bytes, like that. So that is the reason why we will going to have these kind of data types, very important. Thank you very much.